today we're going to review, which is Q equals MC delta T. Then we're going to learn a new equation, and then we're going to put the two equations together. So where Q is your heat equals M, which is your mass, C, your specific heat, delta T, your change in temperature. Okay, so the review problem is, what is the specific heat of aluminum if the temperature of a 28.4 gram sample of aluminum is increased by 8.1 degrees C when 207 joules of heat is added? So first of all, let's look at Q. Or what do we have a Q value? Yes, we do. It's 207. 207 equals, and then we have M, which is my mass. Remember, the only equation that has specific heat in is this equation, Q equals MC delta T. So mass is 28.4 grams. And now then we have to multiply by C. Do we have a C, which is specific heat? No, that's what we're trying to find. C. And then delta T, change in temperature, final minus initial. But in this one, it says it was increased by 8.1. So that is your change in temperature. So we're going to multiply that by 8.1. Okay, if you plug those in and you solve for that equation, okay, so 28.4 times 8.1, find that, divided by 207, you should get an answer of 0.90. Unit on this is joules, that, grams per degrees C. Okay, so that's how you do a specific heat problem. Now we're going to look at a new equation. We're using a new equation, which is Q, which is still your heat, equals N, just like when we did PV inert, N is your number of moles, and your delta H. Delta H is your enthalpy change, okay? Your enthalpy is, so we're looking at, if we're looking at delta H, we're looking at the change in enthalpy, and enthalpy is the sum of the internal energy of a system. So we're looking at the change of energy in a system. So if we look at number 2, it says how much heat will be released when 6.44 grams of sulfur reacts with excess oxygen according to the following equation. So we're given an equation, we're given our delta H. So we know our delta H, so we don't need that, but we need moles. But we're given grams of sulfur, right? So we're going to have to do a can't do railroad tracks on here, so we're going to do it this way. 6.4 grams of sulfur. And we know that this is 1 mole over, we need to get the molar mass of sulfur. And what is the molar mass of sulfur? The molar mass of sulfur is 32 grams. If you plug that in, 6.44 divided by 32, you should get an answer of 0.2 moles. Okay? So now to do our math problem for this, it's Q equals N times our delta H. So now all we have to do is put in our N value, which is 0.20, times our delta H is negative 791.4. Very easy mathing for that one, okay? And our answer that you should get when you do that out, you should get a negative 79.5, and our unit on that is kilojoules. Okay, because that's kilojoules per mole. So therefore the moles cancel out, and the only unit that's left is my kilojoules. Okay, so it's in kilojoules. Now, if you look at this delta H here, is this an exo or an endothermic reaction? It's a negative, so therefore it is an exothermic, right? So therefore it gets hot, and therefore heat is released. Okay, let's look at another problem. It says how much heat will be released when 4.72 grams of carbon reacts with excess oxygen according to the following equation. Okay, we're given our delta H. We're trying to find our heat that's released. So we need to convert that 4.72 to moles. So 4.72 grams of carbon 1 mole, 12 grams. Okay, you do your math on that. 4.72 divided by 12 should give you 0.39 grams. Okay, so now we got to calculate our Q value. Our Q is N, which, oops, I had the wrong unit on there, didn't I? 0.39 times my delta H, which is negative 393.5, and you get an answer with your math of a negative 155 kilojoules. Got it? Okay, let's try one more. How much heat will be absorbed when 38.2 grams of bromine reacts with excess hydrogen according to the following reaction? Now we have a delta H of a positive exothermic or endothermic. Is an endothermic reaction, therefore heat is absorbed. So does this get hot or colder? It gets colder, right? So we need 38.2 grams of bromine. 1 mole. And the molar mass of bromine is 160 because it's Br2, right? Now, if I do my math on that, 38.2 divided by 160 gives me 0.24 moles. And my Q value is my number of moles, which is 0.24, times my delta H, which is 72.8, equals, and you should get an answer of 17.4 kilojoules if you did your math correct. Oh, now let's put the two things together here. Now we are doing we're putting them in a calorimeter. Now in a calorimeter, there is metal ones, but the easiest ones if you take a styrofoam cup, because that will insulate it. It won't change as much your heat, like holding your heat. So a lot of times when we do calorimetry experiments in the classroom, we'll just take a styrofoam cup, put water in it, put a cover on it, and then you will take the temperature before. Then you add whatever you have in there, and you stir it up, and so it dissolves, and you take your temperature after. So that's how you're going to do a calorimetry experiment. So now the problem number says, when a 25.7 gram sample of sodium iodide dissolves in 80 grams of water in a calorimeter, the temperature rises from 20.5 to 24.4 degrees C. Calculate the delta H for this process. Okay, so let's say what do we know here? In my sodium iodide, we know we have 25.7 grams. What else do I know? I know that I have 80 grams of water, right? You with me on that? And we also know that the temperature change, our delta T for that value is, what do you get when you subtract the two? You should get 3.9 degrees C. The wrong way, guys. 3.9 degrees C. That's my delta T, right? So now we have to figure out, what do we need? So if I look at that, what do I know? So can I figure out my Q value? You might use Q equals MC delta T. We know that our C, you always need to know that our water The specific heat of water is 4.18. So let's look at this equation. So we can find our Q, we can find our heat. We're not going to find our delta H yet, we're going to find our heat. So Q equals, and we need to have the mass. What's all in that calorimeter? Is it just the 25.7? Or is it just the 80? No, it's a combination. So you have to add the two of those together. So we're going to add 80. I'm going to parentheses here. 80 plus 25.7, because that's all what's in the calorimeter. Everything that's in the calorimeter goes in there. That's your total mass. Okay, so now that's your mass. Your C is 4.18. That is the specific heat of water. And we know our delta T was 3.9. Right? If you do your math on that, you should get 17. 17 point 1000, that's a positive, equals 1724.8. Unit on heat is joules. Okay, so that gives me my Q value. Now we need to find our delta H. Okay, if I look up on the top here to calculate out delta H is kilojoules per mole. Kilojoules per mole. So now I'm in joules, right? So we need to now do our math. We need to change that over there. We need to change that to kilojoules. So that would be 1.724 kilojoules, right? And we need to find out how many moles that is. So we now need to find our moles. But we need to find our moles of sodium iodide. So now we're going to find our moles of sodium iodide. Let's do it. Insert another chart in here. Let's see if I can do that. Insert table 2 by 2. So let's slide this over. And that over. I should probably change this over here, guys. I'm sorry. 80 grams, 3.9. Put that in the wrong place. So now we need to get our moles of sodium iodide. So 25.7 grams. We need to convert that to moles. So 1 mole. And we know that the molar mass of sodium iodide is 149. If you add that up, grams. That, when you calculate that out, should be 0.1745. Moles. Everybody with me on that? So now to calculate out what we need to get our delta H, and delta H is my kilojoules per mole. Let's copy that equation and put that down here. So we have our kilojoules, right? we have our moles. So if we take our 1.724 kilojoules, divide it by our moles, which is 0.1745, we get a delta H of 10.1 kilojoules per mole. Make sense? Because first of all, we had to get our moles. Once we got that, once we did our Q, then we can find our delta H. So let's do another problem like that. When I have a 16.9 gram sample of sodium hydroxide dissolves in 70 grams of water in a calorimeter, the temperature rises from 22.4 degrees C to 86.6 degrees C. Calculate the delta H. So what do I know? I have 16.9 here, 16.9 grams. I have 70 grams of water, and we know our delta H. That is 64.2. So we're finding, or sorry, delta T. I'm just going to copy my delta here. Delta T equals 64.2 degrees C. For some reason, I keep on hitting the comma instead of the period there, ladies and gentlemen. So no, that's all I know in that problem, but we need to find our delta H. So we need to now find our Q value. So Q, which is in our heat in joules. So Q, I need to get rid of this underlined sign. Q equals our mass. What is our mass in that calorimeter? So we have to add our 70. That's what's in our calorimeter. Plus our 16.9. And that is our mass. C, which is our specific heat, and we're talking of water because that's what's changing in temperature. Our water is changing temperature, 4.18. And our delta T. Delta T was 64.2. So if you do your math on that, you should come up with 23.34. Or you'll come up with, if you wanted in kilojoule, 23.34 kilojoules. Because it will just automatically put it in kilojoules. 23.4 kilojoules. Initially, you'll get it in joules. So you should have got a bigger answer in joules, right? You should have got 23,400 joules. So that gives you your joules. Change it to kilojoules. So now we need to find our mass. So let's do one of those charts again there because we need to get our moles of sodium hydroxide. So let's do insert table 2. Okay, so we have 16.9 grams of sodium hydroxide. We need to convert that. So 1 mole, where 1 mole was on, for some reason it went there. 1 mole. And we know that this is 40 grams. So now if you calculate that out, 16.9 divided by that, you should get 0.4225. Get that? That now is your moles. Now we have our kilojoules here. We have our moles here. So now to get our delta H equation, our delta H is kilojoules per mole. So 23.4 divided by our moles, which was 0.4225. We now get our delta H value of 55.2. And our unit on that is now kilojoules per mole. Last problem we're going to try, ladies and gentlemen. So now we have 12.8 grams of KCl dissolves in 75 grams of water in a calorimeter. The temperature drops from 31 to 21.6. Calculate out the delta H. So we know we have 12.8 grams of KCl, and we know we have 75 grams of water. And we know that our delta T, I'll just go insert special character. Our delta T, so our change in temperature there. If you look at that, you should get a negative 9.4 because it went down in temperature, so it's a negative 9.4 degrees C. Wrong way. So now we can figure out our Q value, right? So our Q equals our mass. So our total mass in our calorimeter was 12.8 grams plus our 75 grams. Our C value, because we still have water in our calorimeter, we're looking at our liquid. So that's 4.18. And our temperature, our delta T, is negative 9.4. So when you calculate that out, you should get, I did math up here, let me find my, okay, negative 3453 joules. I want to put that in kilojoules, that would be 3.453 kilojoules. You with me on that? Now we need to have our moles. We need to have our moles of KCl. So we have 12.8 grams of KCl. We need to convert that to moles. And the molar mass of KCl is 74.55. When you do your math on that, I have no idea why this underline sign keeps showing up here. Equals, if you do your math on that, you should get 0.1717 moles. So now I have my kilojoules. I have my moles. And my equation for my enthalpy is this, my delta H. Kilojoules per mole. So we have our kilojoules, which is 3.453, divided by my moles, which is 0.1717. And when you do your math on that, you should get an answer of 20.1. Kilojoules per mole. Ladies and gentlemen, you should be able to figure these out now. So you have an assignment that is being able to do both kinds of these problems and putting them all together. Good luck.